Okay, chemistry time again. This is gonna, I forget what the exact title was yesterday, but this is part 2 of that. And the only thing we're talking about is significant figures. We're just gonna go real quick. This should not take very long. This is just gonna finish up what we started yesterday. We're going through the rules. We had talked yesterday at length, really. I would say probably about half of what I talked about yesterday was the reasons why we need to use significant figures to indicate precision. But now we're going to talk about specifically how, in a problem-solving way, we would go about this. Yes?
We also talked about how 3.28 feet is not exact.
That's right. We did talk about that. Thank you. 3.28 feet equals 1 meter is not exact. Excuse me. What does exactness mean? No. Exactness indicates what property of data analysis? Precision. Precision. This is precise. This is exact to 3 significant figures. This is an exact value. It has infinite sig figures, significant figures. It is 1. It could be 1.000000 if you needed it to be, but it is exactly 1. That's what the word exact means. This, 12 inches equals 1 foot, is exact. There are exactly 12 infinite zeros. Both of these have infinite significant figures because it's exact. They're exactly, by definition, 12 inches and 1 foot. That's what we mean by exactness. So what do the rest of these have? How many sig figs? 3. What does that give you a hint about how we calculate sig figs? Well, what's the rule here? Why does this one have 3? All of these are significant because they're what? What kind of numbers are these? These are non-zero digits. All non-zero digits are significant. Literally, by definition, 90% of the time, this is the only rule you need to use. Do you get what I mean by 90%? Because of the digits 0 through 9, all of them except 0 are always significant. So 90% of the time, this is the only one that counts. You only need to think about this. In each of these, they're non-zero and they're significant. 0 is significant if, here are some rules. It's, excuse me, between significant figures. 0 is significant if it's between significant figures. Nope, that's not what significant means. Yeah, 3.03. Is it significant? Yes, because it's between significant ones. This one's significant and this one's significant. We know because those are non-zero. So this 0 is significant too. What about 303? Is this one significant? Yes, because it's between significant figures. And it's also significant if it is after a decimal and after a significant figure. I'm going to start this right now. We abbreviate significant figure as sig fig a lot of times. A little rhymey, sig fig. So in that case, 3.00. Is this 0 significant? Try again. Yes, because it is after a decimal and after a sig fig. What does this indicate? Remind yourself, what are we doing this all for? This indicates what property of data analysis? Precision. This indicates precision. This tells me that we measured to the 100th spot and it's exactly 3. What about this? Is this one significant? Try again. No, it's not. This one's not because it's not after a decimal and, not or, but and after a sig fig. It's not that. So this one is not significant. But this one is yes significant. If it is after a decimal and after a sig fig, it is significant. But if it's only after a sig fig or only after the decimal, it's not significant. It does need to be there because what is this 0 acting as? You've heard it's a placeholder. This tells us that it is 300. We can't just write this. That's not 300. This tells us that it is the hundreds spot or the 1 spot but we only can measure, this is only accurate to the nearest what? 100. This is only accurate to the nearest 100. So what does that mean? This could be anything. The actual value could be anything from 249.444 repeating 9, because that would round everything up, to 349.444 repeating less than, or just 444 repeating, right? So anything in between these would round to 300, wouldn't it? No, this would have to be 344, sorry. Anything between these would, wait, this could be, I'm sorry. Could this? Yeah, that could also be a 4. Anyway, anything between these would round to 300. Does that make sense? So we still write 300. It's just that this 0 is not significant. How many sig figs here in this value? No, try again. 1. Just 1. Just the 0 is significant. Just the 3 is significant. Just the 3 is significant. How many sig figs in this? How many sig figs in this? 3. This 0 is significant, and it's after decimal. Hey, but I had a question. It doesn't. None of the rules so far say next to a significant figure, do they? So you just made that up. You just made that up. Yeah. What's up? Yep. The 3 is significant. Remember, all non-zero digits are significant.
So on the bottom one, that middle 0 is significant.
No, because it's not after decimal. The decimal's here. But that's not one of the rules. After decimal and after a significant figure is the rule. Yep.
That's why it has and in a box.
Let me think if that would cover all of the cases. I think that covers everything. What about this? This would be a weird way to write anything. Is this 0 significant? No, it doesn't matter. Not only is it not significant, it means nothing. That's why we don't write it. Oh, hey, what about this? What if we did find, here's where it gets a little bit more interesting. What if we did find that the value was actually, it is exactly 500, but we don't have the precision. We can't say 500.0 because there's no tenths. We're not measuring to the tenths. Our instrument can't measure the tenths for whatever reason. But what if we are measuring to the ones, and we find that it is 500. It's exactly 500, but we can only measure the ones. What do we do then? Well, there are 2 ways. This is the way that I was taught and that we historically have done it. If we put a line over it, that means that this 0 was recorded to be significant. This means, yes, it's significant. And that would obviously mean that this one is 2 because it's between 2 of them. The other way I've seen this is becoming more prevalent is we just put a period after it. So there's the decimal place, which means that these are all measured values. These are all significant, but there's no decimal after it. There are problems with both of these. What's the problem with this one? Well, if we're writing this in a manuscript, that could just be the period at the end of the sentence. We also use this symbol in math to mean repeating. We usually only use that for decimal, so that doesn't come up quite as much in this. But there are problems with both of these. You just have to kind of understand which one is being used at the time. And those are pretty infrequent. Usually we don't see those. Usually there's decimals to be recorded afterward. Put both. Are you trying to say put both? Yeah, just do them both. Yeah, or you could just write, this is significant. You could do that too. Anyway, and then this idea of exact values, these are only for definitional things. Does anyone have a composition notebook handy? Yes. There's a whole table of values in the back. The conversion factors. Look at the conversion factors. Several of those things with the buttload of decimals. Maybe there's only 4, I don't know. But like, for instance, liters to quarts is probably on there. That is not exact. That is not exact. And really, strictly speaking, 2.54 centimeters in an inch is not exact. If I remember right, it's 2.54000. And then after that, there are some other digits. So really, that's only got 6 significant figures, if I'm right. You look it up. You can look up what that value is. But that's not exact. You have to be careful with the significant figures. Now, here's the rule. This is what we use all of this for. Any calculation can only have the precision of its least precise, I was going to say factor, but I don't really necessarily want to use that. I'll just put figure. So whatever calculations, whatever stuff is going in the calculation, our answer can only have the significance, it can only have the precision of the one that has the least. It's really easy, especially when you're using a calculator, to accidentally generate what we call artificial precision. The calculator, because it's doing math, it's just doing the arithmetic, is going to assume that every value you type in is completely significant. And it's going to give you as many significant figures as it possibly can. It's going to spit out 15 decimal places if it can. Right? If you put in 7 divided by 3, it's going to go on forever. Even though both of those things, you put in 7 and 3 only have one sig fig. So it's really up to you to determine how many significant figures there are. Because 7 divided by 3, if those are just straight math values, those are exact numbers. But if we've actually measured them, those are not exact numbers. They're probably rounded. And so we have to be careful of that. So for instance, Alejandro finds the length of his hand to be 8 1/4 inch. What is 8 1/4 expressed as a fraction? Or sorry, expressed as a decimal? 8.25. What's the precision here? Hundredths. So our answer can only be in the hundredths. And then when we convert to the centimeters and meters, and you'll find this in a second, when we convert to centimeters and meters, when we get to meters, it's not going to be the hundredths spot. We're not really worried about places. There are exceptions to that, but we're not really worried about places. We're worried about total number of significant figures. How many is this? 3. That's where. So even when we convert it to meters, it'll be 0.00 whatever it is, but that'll still be only 3 significant figures. The exception to that, that's multiplication. We use the right number of significant figures in multiplication. When we're doing addition and subtraction, and this comes up quite a bit less frequently, for addition and subtraction, use the least number of decimal places. This is still true for it. We just calculate, or we think about precision in a different way for addition and subtraction. For multiplication and division, we think about it in just straight up number of significant figures. When we're doing addition and subtraction, we're thinking about number of decimal places. I think that's everything. We've talked in physical science, and if you forgot, there's a video that I just did recently for the physical science class this year. But we talked in physical science about the ideas of accuracy and precision. If you need a refresher on that, you can watch that video. It's in your book. You need to know the idea of accuracy and precision. I think they were vocab words, weren't they? Yeah. So you should be familiar with them. If you want to hear me explain it, there is a YouTube video you can watch about it, which is also linked in the description of the part 1 of this. So, do you have questions about any of this? What's up, Tiana? Yep. Because what these mean is that I have measured my value to tenths, hundredths, thousandths, 10,000th, 100,000ths, millions, 10 millions. That means I've measured this to the 10 millionths of whatever this is, and I have still found it to be exactly 3. And that's extremely valuable. That indicates that this is an extremely precise value, and we need to keep those zeros. So yeah, every 0 afterwards is significant. Whereas if we had this, that means nothing. You see why to the left of the decimal, I mean, those are just placeholders. That's not indicating measurements. My actual precision here is still just one significant figure. I only measured to the tenths. Yes?
Say you have to measure to 3 significant figures, and the number is 0.0003. This is already 3 significant figures. I mean, like, so say one more 0 where the 3 is supposed to be, and then decimals. Yeah.
Okay, so now we're rounding this to 3 sig figs, right? Is that what you mean? Yeah, it's just 0.000 is what it is. That's the rounding. Yeah.
So
Yeah. Yeah, that would be, I would say that's probably not a good measurement. Like if we know it's only accurate to the thousandths, and we have some data showing it's the 10,000ths, that basically means that data is meaningless. So, good questions. Other questions? Part of your test will be just straight up, here's a number, how many sig figs? And then a lot of your test, and from now on your test will be, here's the math. Have you done the sig figs the right way? I usually am pretty lenient on it, but get more strict as we go on. Like in advanced chemistry, when they do a wrong number of significant figures, even if it's only off by 1, I just take off a point. I just put SF minus 1, like they have the wrong number of sig figs. If they do it egregiously wrong, or if you even, at this time, do it egregiously wrong. Like if you had actually, if this is what you were doing, 7 divided by 3 equals, and you got, do it real quick on a calculator just so I can illustrate my point. So just 7 divided by 3. It very well might be. Is that 2 point? So you write this. You write this, because you're like, I should be as precise as I can. Then that is, I will even at this time put 1 minus significant figures. Because that's just wrong. How many should it be?
1.
If these are measured values, if we have 7 inches divided by 3 cats, I don't know, it doesn't really matter, but those are measured values. This is not a fraction, they're measured values. Yeah, we only have 1 sig fig, so the answer is 2. 2 inches per cat. I don't know what we're measuring here. Amount of string cheese eaten, I don't know. Do you have questions before we go on? So like I said, some of them will just be how many sig figs is this, but from now on, anytime we're doing math, watch out for this, and you'll get better at it. It's something you just kind of do as you go along. It'll help to do it on your unit conversions worksheets. Questions about those that you would like recorded on video? Oh yeah, we did forget that yesterday. I'll have to change the title of the video, but you're right, we did forget to talk about rate conversions yesterday. We should probably already know about it, but I'd also like to have it on video. So for rate conversions, let's think about, in boys' toilet here, I like to use this example because it's kind of gross and maybe it'll make you remember it. In boys' toilet, there's a urinal, and the urinal on the top says 1.3 GPF. What does that probably stand for? Can you guess? Yeah. Gallons per flush. Gallons per flush. I want to change that to, let's say, oh, this isn't going to work great for this because I can't really convert flush. No, we're going to do something different. Gallons per, we're just going to say that's how, it's always running. This is how many gallons run per hour out of it. That'll make it easier. Gallons per hour. Let's say I want to convert it to gallons, let's say liters per minute. Okay? By the way, MIN is minute. What's lowercase m? What abbreviation is lowercase m? Meter. What's MIN? Minute. MI is mile. So don't get confused between those. You need to write MIN for minutes. Anyway, so if we're converting from gallons per hour to liters per minute, I usually, it doesn't really matter. These you can switch between them, but I usually do the unit in the numerator first, just because that's what we're already used to doing. So gallons to liters. We're just going to use an inexact value for that with at least 2 sig figs so we get our answer to have the right number of sig figs. And then, since hour is already in the denominator, we put in the numerator to eliminate it, or to reduce it to 1 is what I mean to say. What are we going to? From hours to minutes. So is it accurate to say whatever unit you want to get rid of, put on the bottom of the next fraction? No. If we're being accurate, we should say whatever unit you want to reduce to 1, put it on the opposite side of the fraction bar. That's the actual rule. Usually it is on the bottom, because usually we're only dealing with values in the numerator. Anyway, how many liters are in a gallon? Look at your little chart in your notebook. Right, that's why I asked you to look. I want liters in a gallon. No. That's not very useful for this. I think it's about 3.98.
Well, 1 quart is 0.9.
Let's just use this.
And there's 4 quarts in a gallon.
Let's just use this. 3.98. I think that's roughly right. Someone in the comments can tell me. 1 hour is 60 minutes, as you probably are aware. Multiply by everything on top. 1.3 times 3.98. Divide by everything on the bottom. Divided by 60. Answer? Answer? I want to have an answer and a corroboration, please. Where's your calculator, best friend? Uh-oh, go get it real quick, because you're going to need it today anyway, so. Answer?
0.086, which has to be significant.
So? 0.0, 0.09 what? Liters per minute is the answer. Hours reduced to 1, gallons reduced to 1. We're left with liters divided by minutes, which we pronounce as liters per minute. That's the right answer. This is how we convert rates. Rates are always some quantity divided by another quantity. We pronounce that as per. Other questions? Thank you for reminding me. Other questions? Bye.